Hey everyone. All right, let's just get straight into it. If you've been writing Python for a bit, you already know that eventually a script can turn into this massive, tangled web of code that's just a nightmare to manage. Well, in this explainer, we're going to fix that. We are talking about Python functions. I want you to think of a function as your own personal mini factory. Instead of doing everything by hand in a chaotic, messy way, we're going to build a super efficient assembly line. Raw materials go in, they get processed perfectly, and a finished product comes right out.
Here's a quick look at our roadmap for today. We'll start by looking at the power of functions, move into how we pass data using arguments and parameters, figure out how to get results back with return values, trace the exact flow of execution, and then finally, we'll demystify the invisible boundaries of variable scope.
Okay, part 1, the power of functions.
Now, you know Python gives you some pretty great built-in tools right out of the box, but a custom-crafted function, that is made entirely by you for your exact specific needs. And this perfectly illustrates why we even bother in the first place. It's the DRY principle. Don't repeat yourself. Let's be totally honest. Absolutely nobody likes doing the exact same work twice. If you're constantly copying and pasting blocks of code, you are working way too hard. Writing a piece of logic once and using it 100 times, that is the ultimate goal here.
And honestly, it's a beautifully simple transformation. By using the def keyword, which is just short for define, you take a chaotic repetitive text file and package your logic into a clean named unit. You literally just type def, name your function, add some parentheses, and indent your code underneath it. Boom, you've just built the very first piece of your assembly line.
Moving right along to part 2, arguments and parameters.
So we've got our mini factory set up, right, but how do we actually get the raw materials inside to be processed? People mix these two terms up all the time, so let's get it crystal clear right now. Think of parameters as the empty receiving docks at your factory. They're just the variables sitting inside the parentheses when you first define the function, basically acting as placeholders. Arguments, on the other hand, are the actual raw materials. They're the real data, the actual values that get dropped off at the dock when you actually call the function into action.
And here is where it gets really fun. You can totally pass arguments by position, where the order matters perfectly. But you can also use what we call keyword arguments. Think of keyword arguments like perfectly labeled ingredient jars sitting in a pantry. By explicitly stating the parameter's name when you call the function, like typing out color equals white or animal equals rabbit, the order suddenly doesn't matter anymore. You just grab exactly what you need without stressing over which spot it was supposed to be in.
Now you can also set up fallback values, which we call default parameters. But if you want to keep the factory running smoothly, there are a few strict rules. Rule number 1, your default parameters absolutely must come after your non-default parameters when you're defining the function. If you put them out of order, Python gets hopelessly confused about what argument is supposed to go where.
Rule number 2, you can totally have multiple default parameters, that's fine, but they have to sit grouped tightly together at the very end of your parameter list. You want to keep your required, non-negotiable inputs up front and push all your optional fallbacks to the back.
And rule number 3, default values are evaluated exactly once, right at the moment the function is defined. They are not reevaluated every single time you call the function. So just a huge heads up here, be extremely careful if you're using mutable defaults like empty lists, because they can definitely start behaving in weird, unexpected ways if you aren't paying attention.
All right, part 3, returning values.
It is time to check out the shipping department of our factory. Look, a lot of beginners will just print the results inside their function so they can pop it up on the screen and look at it. But printing is literally just looking at the product. The return statement actually hands the computed, usable result right back to the main program. That is what makes functions truly powerful. You're shipping a finished product out that you can store in a variable, pass along to a completely different function, or use in some complex math equation later on.
Python's shipping department is pretty incredible too. You can actually return multiple values all at once just by separating them with commas, and Python will conveniently bundle them into a neat little tuple for you. From there, you can unpack those values right into separate variables. But I do need to give you a quick warning. If you forget to include a return statement entirely, Python will just shrug its shoulders and hand you back none.
Which brings us to part 4, the flow of execution.
So we know how to build the factory, and we know how to ship the product. But how does Python actually read all this code chronologically? Well, it reads top to bottom, just like a book. But here's the clever trick. When it sees a function definition, it registers it silently, without actually running any of the code inside. It's this jump and return behavior that really is the secret magic making your code highly composable.
Let's trace it out together. First,
Python speeds down the page and registers the definition in its memory. Second, it encounters the actual function call later down in the script. Third, and this is the fun part, execution literally jumps all the way back up the page to run the code inside the function body. And finally, when it's totally done, it just pauses and returns control right back to the exact line immediately after the call. It's like a beautifully choreographed dance.
Finally, Part 5, Understanding Variable Scope. Scope is notoriously tricky for people learning Python, but honestly, it's really just about the invisible boundaries on our factory floor. Let's use a bit of spatial imagination here. Think of global scope as this wide open landscape. Variables that are created out here can be seen by absolutely everyone. Local scope, on the other hand, is like a tightly enclosed box. This represents the inside of your function. Variables created inside this box are completely trapped. They cannot be accessed by the outside world at all.
So, here are your absolute golden rules for scope at a glance. Number 1, Python always checks inside the local box first to find a variable. Number 2, if it has to look outside to the global landscape, it treats it as read-only by default. You can look at it, sure, but you can't touch it or modify it unless you explicitly declare it global. And number 3, that enclosed local box, it's completely temporary. It gets built the second the function runs, and it is instantly destroyed the moment the job is done.
I've got to add a massive caution sign right here, though. While you technically can use the global keyword to force your function to reach out and modify that wide open landscape, please don't overuse it. Relying on global variables creates these incredibly subtle, nightmarish bugs that are basically impossible to test and debug. Keeping your variables local is what keeps your functions beautifully self-contained and entirely predictable.
Let's wrap this up with our conclusion and key takeaways.
By mastering parameters as your inputs, returns as your outputs, really understanding that jumping flow of execution, and respecting the strict boundaries of variable scope, you now have the exact tools you need to write clean, professional, and super readable programs. So I want to leave you with this thought. Go pull up that script you were working on yesterday. Take a good look at it. Where are you repeating yourself? Where can you apply the DRY principle today to save yourself a massive headache tomorrow? Take everything we talked about, build some custom functions, and go organize that messy code. Thanks for hanging out with me for this explainer, and happy coding!